This is another very important 5 marks question from the chapter Electric Charges and Fields. That is, obtain an expression for the electric field at a point on the equatorial plane of an electric dipole. Let's see this question. Consider a point P on the perpendicular bisector of the axis of an electric dipole at a distance r from its midpoint. The dipole moment of the dipole P directed from negative charge to positive charge, whose magnitude is P is equal to Q into 2A. Let's see the diagram now. How to draw the diagram first. So first we have to draw the dipole. Dipole means it consists of two similar charges equal and opposite. So this is the two charges we'll consider here, positive charge and it is the negative charge, and we'll consider on point P here on perpendicular bisector to the dipole at a distance r. And what is the distance between the two charges? Electric distance of the electric dipole, it is the 2a. And from the center to this positive charge it is the distance a, and from center to negative charge distance it is a. Now what is the direction of electric field due to positive charge at point P? Means due to positive charge the direction of electric field lines, it is always radially outwards. Now here the direction of electric field is making an angle theta with the direction of dipole moment P bar. And what is the distance from positive charge to point P? Means by using the Pythagoras series we can use this r square plus a square. At the same time, direction of electric field due to negative charge. Direction of electric field due to negative charge, it is radially inwards. Radially inwards. And the distance from positive charge, negative charge to point P, it is also r square plus root over r square plus a square. And now here this is the direction of negative electric field due to negative charge. It resolved into two components. These two electric fields resolved into two components. So here it is the E plus Q cos theta, and vertically upwards E plus Q sin theta. At the same time, again this electric field due to negative charge also resolved into two components, E minus Q cos theta, and the vertically downwards E minus Q sin theta. Now let's see that formulas. What is the electric field due to positive charge? Electric field due to positive charge plus Q, E plus Q is equal to 1 by 4 pi epsilon naught Q by distance square. Here distance it is root over r square plus a square whole square. Square root will get cancelled. So we'll get the formula finally 1 by 4 pi epsilon naught Q by r square plus a square. And next electric field due to negative charge. Electric field due to negative charge minus Q. So E minus Q is equal to 1 by 4 pi epsilon naught Q by root over r square plus a square whole square. Here also square root will get cancelled. So 1 by 4 pi epsilon naught q by r square plus a square. So here the magnitudes are both are equal. The magnitude of electric field due to positive charge is equal to the magnitude of negative electric field due to negative charge. Both are equal in magnitude but in different directions. So here these electric fields are resolved into components because these magnitudes are equal. These vertical components will get cancel each other and horizontal components will add up. So then what is the total electric field here means the net electric field E is equal to E plus Q cos theta plus E minus Q cos theta. But here this net electric field, it is opposite to the direction of electric dipole moment, so we'll take the negative sign. So if you observed here in the diagram, the direction of dipole moment it is negative to positive, but the horizontal components it is opposite to the direction of dipole moment, so we are taking here negative sign, and we take the common term here minus of E plus Q plus E minus Q into cos theta. So already I given in the previous thing, so both magnitudes are equal, so we can write this into minus 2 E plus Q into cos theta. From the diagram, cos theta is equal to adjacent by hypotenuse. That hypotenuse it is root over r square plus a square. Instead of root we can write whole power 1 by 2. And we know already E plus Q formula, so substitute here minus 2 into 1 by 4 pi epsilon naught q by r square plus a square whole power 1, nothing is there, into cos theta. Cos theta means a by r square plus a square whole power 1 by 2. So if you simplify this, minus 1 by 4 pi epsilon naught 2a into q is nothing but p by, so base are common, powers will add up, r square plus a square whole power 3 by 2. So we'll use the condition if r is much greater than a, then a is negligible here. So E is equal to minus 1 by 4 pi epsilon naught, so p by r square whole power 3 by 2, 2 will get cancelled, so it becomes finally minus 1 by 4 pi epsilon naught into q by r cube. So this is the magnitude of the electric field due to electric dipole on equatorial plane.